Hi, I am a tutor in Uplatz. Today we are going to discuss about basics of programmable logic controllers. Description: this training introduces the basic hardware and software components of a programmable logic controller. It details the architecture and basic instructions set common to all PLCs. Basic programming techniques and logic designs are covered. This training describes the operating features of the PLC, the advantages of PLC over hardware control systems, practical applications, troubleshooting, and maintenance of PLCs. Objectives: at the end of the training, the participant should be able to describe the major components of a common PLC, interrupt PLC specification, apply troubleshooting techniques, convert conventional relay logic to a PLC language, operate and program a PLC for a given application. Course contain history of programmable logic controller, relay ladder logic, central processing unit, input output system, programming and peripheral devices, programming concepts, applications, troubleshooting and maintenance, advantages of PLC, less wiring between devices and relay contacts are done in the PLC program, easier and faster to make changes, troubleshooting aids makes programming easier and reduce downtime, reliable components make these likely to operate for years before failure. PLC origin developed to replace relays in the late 1960s, cost dropped and became popular by 1980s, now used in many industrial designs. Historical background: the Automatic Division of General Motors Corporation specified the design criteria for the first programmable logic controller in 1968. The primary goal to eliminate high costs associated with inflexible relay control systems. The controller had to be designed in modular form so that some sub-assemblies could be removed easily for replacement or repair. The control system needed the capability to pass data collection to the central system. The system has to be reusable. The method used to program the controller had to be simple so that it could be easily understood by plant personnel. Programmable logic controller development. 1968, programmable concept developed. 1969, hardware CPU controller with logic. Instructions, 1K memory and 128 I/O points. 1974, use of several multiprocessor within a PLC, timers, counters, and arithmetic operations, 12K of memory and 1024 I/O points. 1978, remote input-output system introduced. 1977, microprocessor-based PLC introduced. 1980, intelligent I/O modules developed, enhanced communication facilities, enhanced software features, example documentation, use of personal microcomputers as programming aids. 1983, low-cost small PLCs introduced. 1985, on networking of all levels of PLC computer and machines using SCADA software. Programmable logic controllers, definition according to NEMA standard ICS 1978. A digitally operating electronic apparatus which uses a programming memory for internal storage of instructions for implementing specific functions such as logic, sequencing, timing, counting, and arithmetic to control through the digital or analog modules of various types of machines or process. Leading brands of PLC, American, one Allen Bradley, Gold Modicon, Texas Instruments, General Electric, Westinghouse, Cutterhammer, Square D, European Siemens, Klockner and Mauler, Vesto, Teddy Mechanic. Leading brands of PLC, Japanese Toshiba, Omron, Anak, Mitsubishi. Areas of application: manufacturing, machining, food, beverage, metals, power, mining, petrochemical, chemical. PLC size: small, it covers units with up to 128 IOs and memories up to 2 kilobytes. And these PLCs are capable of providing simple to advanced levels of machine control. Medium have up to 2048 IOs and memories up to 32 kilobytes. Large are most sophisticated units of PLC family. They have up to 8192 IOs and memories up to 70 kilobytes. Can control individual production processes and entire plant. Tank used to mix two liquids, solenoid A and B, timer, motor, float switch, solenoid for the output. A tank is used to mix two liquids. The control circuit operates as follows. When the start button is pressed, solenoid A and B energizes. This permits the liquids to begin to fill in the tanks. When the tank is filled, the float switch trips. This de-energizes solenoid and A and B and starts a motor used to mix the liquids together. The motor is permitted to run for 1 minute. After 1 minute, as elapsed, the motor turns off and the solenoid C energizes to drain the tank. When the tank is empty, the float switch de-energizes the solenoid C. A stop button can be used to stop the process at any point. If the motor becomes overloaded, the action of the entire circuit will stop. Once the circuit has been energized, it will continue to operate until it is manually stopped. Major processor, power supply, programming device, input module, from the sensors, push buttons, contacts, limit switches, etc. Output module to output solenoid contacts, alarms, etc. These are all the major components of a common PLC. Major components of a common PLC. Power supply provides the voltage needed to run the primary PLC components. I/O modules provides signal conversion isolation between the internal logic level signals inside the PLC and the fields I level signal. Processor provides intelligence to command and govern the activities of the entire PLC system. Programmable logic device used to enter the desired programming that will determine the sequence of operations and control of process equipment or that driven machine. Programming devices, also known as industrial terminal, Allen Bradley, program development terminal, General Electric, programming panel, code Modicon, programmer, Square D. Program loader, EDEC is me. Programming console, key1, Keynes Omron. Types, handheld unit with LED LCD display, desktop type with SCRT display, compatible computer terminal. I/O module, the I/O interface section of a PLC connects it to the external devices. The main purpose of I/O interface is to condition the various signals received from are sent to the external input and output devices. Input module converts signals from discrete or analog input devices to logic level acceptable to PLC process. The output modules convert signal from processor to levels are capable of driving the connected discrete or analog output devices. DC input module used to drop voltage to logic level from input device. Current limiting resistor. Opto isolator is needed to prevent voltage transients from the damage in the processor. It helps reduce the effects of the electrical noise. Buffer filter hysteresis circuit to the processor. AC input module converts the AC input to DC and drops the voltage to logic level from input device rectified processor network. Then opto isolator is needed to prevent voltage transients from damaging the processor. It helps reduce the effects of electrical noise. Then buffer filter hysteresis circuit to the processor. The light emitting diode, photoresistor, dual optocoupler IC, 8-pin DIP is shown here. And the basic DC input circuit is shown in there. The input PLC module, signal CPU. Here the 3 input circuit diagram is shown. The 3 inputs are shown, and the common is shown, and the process, how it goes to the processor are shown here. Input connections, AC is connected like this with L1, L2. DC power supply is connected as shown in figure P, and detailed power supply, DC power supply is connected as shown in figure C. I/O module, DC in AC output module from processor, TTL circuit, then auto isolator is needed to prevent transients from voltage transients from damaging the processor. It helps reduce the electrical effects of the electrical noise. Then amplifier relay triac and resistor to the output device. DC output wiring connections are shown here, and AC output wiring connections are shown in figure 3.9. IBOS circuits, different types of IBOS circuits. Pilot duty outputs of this type typically are used to drive high current electromagnetic flows such as solenoids, relays, valves, and motor starters. These loads are highly inductive and exhibit a large inrush current. Pilot duty output should be capable of withstanding an inrush current of 10 times the rated load for a short period of time without failure. General purpose outputs. These are usually low voltage, low current, and are used to drive indicating lights and other non-inductive loads. Noise suppression may or may not be included on this type of modules. Discrete inputs. Circuits of this type are used to sense the status of limit switches, push buttons, and other discrete sensors. Noise suppression is of great importance in implementing false indication of input standing on or off because of noise. Analog I/O. Circuits of this type sense or drive analog signals. Analog inputs come from devices such as thermocool, strain gauges, or pressure sensors that provide a signal voltage or current that is derived from the processor variable. Standard analog input signals 4 to 20 milliampere, 0 to 10 volt. Analog outputs can be used to drive devices such as voltmeters, X-ray recorders, servo drives, valves through use of transducers. Standard analog output signals are 4 to 20 milliamperes, 0 to 5 volts, 0 to 10 volts. Special purpose I/O. Circuits of this type are used to interfere PLCs to very specific types of circuits such as servo motors, stepper motors, PID, proportional plus integral plus derivative loops, high speed pulse counting, resolvers and decoders, inputs, multiplex, displays, and keyboard. This module allows for limited access to timer and counter presets and other PLC variables without requiring a program loader. So input push button type PLC, the contractor, the motor, and the lamp, which are outputs. Allen battery 1746 1A16 has a PB switch. Input module wiring diagram is shown here in L2. Input module slot in rack and 0 module terminal address I2. Positive way ladder program is shown here. This is the ladder program. I is input. 2 is a module slot number in rack. 0 is out address module terminal I2 0.0 by 0. Here the L1, L2 are the output mile wiring, contractor, and field wiring, motor, solenoid valve, lamp buzzer. The corresponding ladder diagram is shown here. Discrete input. A discrete input, also referenced as digital input, is an input that is either on or off or connected to the PLC digital input. In the on condition, it is referred to as logic 1 or logic I, and in the off condition may be referred to as logic 0 or logic low. Normally open push button, normally close push button, normally open switch, normally close switch, normally open contact, normally close contact are shown in the figure. Off logic 0, PLC input model 24 volt DC, or logic 1, PLC input 24 volt DC. Analog input. An analog input is an input signal that has a continuous signal. Typical inputs may vary from 0 to 20 milliampere, 4 to 20 milliampere, or 0 to 10 volt. Below a level transmitter monitors the level of liquid in the tank. Depending on the level TX, transmit the signal to the PLC can either increase or decrease as the level increases or decreases. The digital output as a discrete output is either in an on or off condition. So large contractors, coils, lamps are examples of devices connected to the discrete or digital input. Below the lamp can be turned on or off by the PLC output if it is connected to. An analog output is an output signal that has a continuous signal. Typical outputs may vary from 0 to 20 milliampere, 4 to 20 milliampere, 0 to 10 volts. Here PLC output is written mode, the electric pneumatic transducer is used and supply pneumatic control valve opens or closes to supply the air. Processor, the processor module contains the PLC microprocessor, the supporting circuit and its memory system. The main functions of the microprocessor is to analyze data coming from the field sensors through input modules, make decisions based on the user's defined control program, and return signal back through output modules to the field devices, field sensors, switches, flow, level, pressure, temperature, transfer, etc. Field output devices, motor, valve, solenoid, lamps, are audible devices. The memory system in the processor module has two parts, a system memory and an application memory. Data table, user program, system. System memory includes an area called executive, composed of permanently stored program that direct all system activities such as execution of users, control system, communication with peripheral and other system activities. The system memory also contains the routines that implement the PLC's instruction set, which is composed of specific control functions such as logic, sequencing, timing, counting, and arithmetic. System memory is generally built from read-only memory devices. Application consists of data table and middleware programs. And the application memory is divided into the data table area and user program area. The data table stores any data associated with the user's control program, such as system input and output status data, and any stored constant variables or preset values. The data table is where data is monitored, manipulated, and changed for control purpose. The user program area is where the program instruction entered by the user are stored as an application control program. Memory design, volatile. A volatile memory is one that loses its stored information when the power is removed. Even momentary losses of power will erase any information stored or programmed on the volatile memory chip. Common types of volatile memory: random access memory, read-write. Read-write indicates that information is stored in the memory can be retrieved, and read-write indicates that the user can program or write information into the memory. Memory design, the words random access refer to the ability of any location address in the memory to be accessed or used. RAM memory is used for both the user memory, data diagram, and storage memory in many PLCs. RAM memory must have battery backup to retain or protect the stored program. Memory design, several types of memories: MOS, HMOS, CMOS. The CMOS RAM, complementary metal oxide semiconductor, is probably one of the most popular. CMOS RAM is popular because it has a very low current drain when not being accessed, 15 microamps, and the information stored in the memory can be retained by as little as 2 volt DC. Non-volatile has the ability to retain stored information when the power is removed accidentally or intentionally. These memories do not require backup battery. Common types are non-volatile, read-only memory. Read-only indicates that the information stored in memory can be read only and cannot be changed. Information in ROM is placed there by manufacturer for the internal use and operation of the PLC. Other types of non-volatile memory: PROM, programmable read-only memory, allows initial and additional information to return to the chip. PROM may be returned to only once after being received from the PLC manufacturer. Program is accomplished by pulses or current. The current melts the fusing links in the device, preventing it from being reprogrammed. This type of memory is used to prevent unauthorized program changes. EEPROM, erasable programmable read-only memory, ideally suited when program storage is semi-permanent or additional security is needed to prevent unauthorized program changes. The EEPROM chip has a quartz window or a silicon material that contains the electronic integrated circuits. This window normally is covered by opaque material, but when the opaque material to expose the ultraviolet light, the memory contents can be erased. The EEPROM chip is also referred to as UEPROM. EEPROM, electrically erasable programmable read-only memory, also referred to as E2PROM, is a chip that can be programmed using a standard programming device and can be erased by the proper signal being applied to the erase pin. EEPROM is used primarily as a non-volatile backup for the normal RAM memory. If the program is RAM is lost or erased, a copy of the program stored on an EEPROM chip can be downloaded into the RAM. PLC operation, Basics of PLC, read all the PLC input devices via the input interface, execute the user program stored in application memory. Then, based on whatever control scheme has been programmed by the user, turn the field output devices on off or perform whatever control is necessary for the process application. This process, sequentially reading the inputs, executing the program in memory, and updating the output, is known as scanning. While PLC is running, the scanning process includes following 4 phases, which are repeated continuously as individual cycles of operation. Phase 1, read scan inputs. Phase 2, program execution. Phase 3, diagnostic communication. Phase 4, output scan. Phase 1 input status scan. A PLC scan cycle begins with CPU reading the status of inputs. The application program is executing the status of the inputs. In the phase 2, logic sort program execution. Once the program is executed, the CPU perform diagnostic and communication tasks. An output status scan is then performed whereby the stored output values are sent to the actuators and the other field output devices. Cycle ends by updating the outputs. This is the output status scan. As soon as the phase 4 are completed, the entire cycle begins again with phase 1 input scan. The time it takes to implement a scan scale is called scan time. The scan time composed of a program scan time, which is the time required for solving control program, and the IO update time, or the time required to read inputs and output, update output. The program scan time is generally depends on the amount of memory taken by the control program and the type of instruction used in the program. And the time to make a single scan can vary from 1 millisecond to 100 milliseconds. PLC communication, common uses of PLC communication ports, changing recent PLC program, uploading, downloading from a supervisor controller, laptop, or desktop computer, posting IO points and memory elements from a remote terminal, linking a PLC into a control hierarchy containing several sizes of PLC and computer, monitoring data and alarms, etc. via printers or operator interface units via use. Serial communication, PLC communication facilities normally provide serial transmission of information. Common standards RS-232 used in short distance computer communications with the majority of computer hardware peripherals has a maximum effective distance of approximately 30 meters at 9,600 baud. Local area network provides a physical link between all devices, plus providing overall data exchange management or protocol, ensuring that each device can talk to other device machines and understand data returned from them. LAN provide a common high-speed data communication, which interconnects any or all devices with the local area. Local LANs are commonly used in business applications to allow several users to share costly software packages and peripherals such as printers and all disk storage. RS-232, 422, RS-485 used for longer distance links, often between several PCs in a distributed system. RS-485 can have a maximum distance of 1,000 meters. Programmable controller networks, dedicated network system of manufacturer, Allen Bradley Data Highway Network, Data Highway, Gold Modicon, Modbus, General Electric, GE Net Factory LAN, Mitsubishi, Belsec Net, Square D, SY Net, TI Specifications, several factors are used for evaluating quality of a programmable controllers when selecting a unit for a particular application. These are listed below. Number of IO ports. This specifies the number of IO devices that can be connected to the controller. There should be sufficient IO ports to meet present requirements with enough spares to provide for moderate future expansion. Criteria, number of logical inputs, outputs, memory, number of special IO modules, scan time, communication software. A detailed design process, understand the process, hardware software selection, develop ladder logic, determine scan times and memory requirements. Specification, output port power ratings. Each output port should be capable of supply sufficient voltage and current to drive the output peripheral connected to it. Scan time, this is the speed at which the controller executes a relay ladder logic program. This variable is used specified as the scan time per 1,000 logic nodes and typically ranges from 1 to 200 milliseconds. Memory capacity, The amount of memory required for a particular application is related to the length of the program and the complexity of the control system. Simple applications having just a few relays do not require significant amount of memory. Program length tend to expand after the system have been used for a while. It is advantageous to acquire a controller that has more memory than is presently needed. PLC status indicators, power on, run mode, programming mode, fault. Troubleshooting, look at process, PLC status lights, alt, something has stopped the CPU, run, the PLC thinks it is okay and probably is. Error, a physical problem has occurred with the PLC. Indicator lights on IO cards and sensors, consult the manuals or use software available, use programming terminal laptop. Desktop item requires when working with PLC. Programming terminal laptop or desktop PC, PLC software, PLC manufacturers have their own specific software and license key, communication cables for connection from laptop to PLC, backup, copy of the ladder program on diskette, CD-ROM or disk or flash memory, none, uploading from the PLC, documentation, PLC manual, software manual, drawing, ladder, program pinout and sequence of operation manual. Examples of PLC software, Allen Bradley, Rockwell software, RS Logix 500, Modicon, Modsoft, Umbran Sysfin, GE Canuck Series 6, Logic Master 6, Quality Power Logic, Texas Instruments, Semantic, Telemechanic, Modicon TS6 Micro. Programming, normally open is shown and normally close is shown. Power flows through these contacts when they are closed. They normally open is true when the input and or the output status bit controlling the contact is 1. Normally close is true when the input or output status bit is controlling the contact is 0. Coils represent relay that are energized when the power flows to them. When a coil is energized, it causes a corresponding output to turn on by changing the state of the status bit controlling the output to 1. The same output status bit may be used to control normally open or normally closed contact anywhere in the program. Boxes represent various instructions or functions that are executed when power flows to the box. Some of these functions are timers, counters, and math operations. And operation rung. Each rung or network on a ladder program represents a logic operation. The rung above, both inputs and A and B must be true, 1 in order for the output C to be 1. In the OR operation, in the rung 1, it can be seen that either the A or B is true to be true or both are true, then output C is true. In the rung above, it can be seen that input A is to be true, then output is to be true 0. Or when A is 0, output is C is 1. Thank you.